some time t, how much is asking. So what actually it is, so you start with this like a container. Initially it is empty and it's having a hole. There's a tap which will supply the water. It will supply at a rate alpha. Then from here decay occurs. What this tap produces the substance. And here what happens through all, what happens, it decays, means amount decreases, no? Decays through all, let's say them. So initially what happened at t equals 0, no substance. Empty tank, no substance of x, empty tank. Now with the time, after some time, what you see, as I open up the tap, as it starts producing, I think you'll feel very comfortable writing rate equations. I don't know how you study in chemistry, but in physics, since we know many other ideas, no, fluid dynamics, that I'm applying. When you open up the tap, initially the tank is empty. So as you open up the tap starts supplying water. It starts supplying water. Then what will happen? This will continue to supply. At the same time, here what happen, as the level of water increases, from here what happen, the water will flow out, no? The water will float. So what actually finally will get a situation of like this. And the one which decayed, no, I'll show some other color. What happened? Teacher just explained me like this only. So in fact, I felt very easy. This is what decayed one. This will supply. Let's take this one. Now this is at time t. It will number present, let it be n, and this is what decayed one. Decayed substance. This is survived. At any time t, that is what it is survived here. And there's a tap which will supply here. Now, you know, what is the rate equation you write it? So first, the rate equation is what we should write here. The rate of production minus rate of decay should be equal to rate of survival. Shall I write? So writing rate equation is what the whole idea of this entire, the successive disintegration, or what all we say, radioactive phenomena. So how to write equation? Okay, finally, okay, we brought some logic here. How to write equation, that one. So shall we say that rate of formation, this particular radioactive substance is being formed, survived or formed, rate of production, this is a rate of decay. So what we write here, rate of formation equal to rate of production minus rate of decay. What is the rate of formation? dN by dt. Rate of production, alpha. Then what is the rate of decay? Lambda n. The very first one, this almost everywhere there are around 10 to 15 numericals are there where we are going to use this method. Decayed substance. Okay, let's write now. So this will be dN by. So once you write this rate equation, rest all mathematics you can manage. So at t equal to 0, what was the substance? It was not present. And at any time t, let n be this one. So therefore this will become minus 1 by lambda log of alpha minus lambda 0 n equal to t, or log of alpha minus lambda 0 n 0 to n, that one. So substituting upper and lower limits. Let me send log on either side. So this will be 1 by alpha is equal to e to power of minus lambda t, or the number n is equal to alpha by lambda. Look at that particular n. It will keep on increase, no? It will increase exponentially. What is this n? The number of the, so what you can say x, no? A radionuclide x, I'll call it, yes. The number of nuclei of x at any time t. Number of nuclei of x at time t. Okay, this is what? This one. How many decade can we write nd? Let me ask that one. How many decade? Okay, let's complete the question. The maximum number of nuclei of X. When it be maximum, I think you know very good, no? Like a fluid dynamics. When the level of water will be maximum. When the rate at which the water entering from the tap is equal to the rate at which water flowing from the hole. So how many nuclei are produced? Those many nuclei decay. Then what happened to the amount of substance? This will remain constant. And when do that will happen? T equal to infinity. That's what he's saying. Put T equal to infinity, then you'll get the maximum. This is number of nuclei of X at any time t. So n max. So what is n max will be? And how do it will vary? It is going to the number survived at any time t. Lambda, it will have some decay constant. Okay, I'll write it, no problem. So some substance will have decay constant. Let me take lambda. Okay, fine. This is thing. Okay, now a few things. I want this, what amount of substance that got decayed. How to find out that one? So I'll just take help of in time t, how many are produced? Alpha t. So number decayed should be equal to alpha t minus n. So what is this? Number of nuclei decayed, alpha t. So what is value of n? Alpha by lambda. They may ask you to plot this graph or all other things. You should be very alert. These many nuclei got decayed, means the substance is being formed and they'll undergo decay. What is that decay? So these many, is it alpha or beta decay? Yes, it can be alpha or beta. We are not sure, but sir, alpha four nucleons will come, beta only one nucleon. Still, you call both of same? Yes, it will be. So altogether, the nucleon alpha beta decay together are called as radioactive decay. That one. A radionuclide X is produced at a constant rate alpha at time t equals the number of nuclei of X are 0. Find the maximum number of nuclei of X, the number of nuclei after time t. N of t, this is what, so these are our answers. Suppose say each decay will generate an energy, and 40% of that energy is utilized to eat up the water. Can we do anything here? For that, what we should do? I'll introduce the ideas here only, so that will be in some better position. In each decay, there'll be some energy released, no? And that energy, what is utilized to boil the water, to rise the temperature of water. So how to calculate the energy? Energy released in each decay, let it be E naught. Of that, what happened? 40% is utilized, 60% is lost, 40% is utilized to boil the water. Then how to calculate the temperature of the water? So this should be equal to, so we know number of decays. No? So what is the total energy released? Energy released. In each decay, let E naught be the energy released in each decay process. Then, so how many decays undergone? ND. So what is total energy release will be ND into E naught. Then what is the efficiency? Efficiency is say like a 60% will put it. So 40% is lost, only 60%. That 60% is utilized to rise the temperature of water. So what is the Q is equal to heat supplied to the water Q is equal to 60%, 0.6 into ND into E naught. And this is what, what is ND? ND we have like this. We have ND like this. So this is Q. So what is for the Q? You can write MS delta T. What is delta T? Change in temperature. You do get problems of all this one. So this is NDM, number decay, not N naught. Please. What is this? Specific heat.